We're given a net of a polyhedron, and I think the first thing to do is to try and sketch this polyhedron. It took me a little bit of time to figure it out actually, but we're going to wrap these squares around themselves. So I'm not going to have a cube because I don't have 6 squares, but I'm going to have a sort of a cube type structure where I've got the front, the top, the bottom, and the back, but these bits are like empty, this here and this here. What's going to happen is that these are going to form to create a square-based pyramid. So if I just put the point in and draw the vertices, it's actually not that bad to do a little sketch of it. And I could do exactly the same on the other side. And we've got ourselves our 3D solid. So we're actually trying to work out the distance between J and K. Now, because, yeah, J is going to end up forming the vertex here, and K the vertex at the other side. So essentially, I'm trying to work out the length. I hope I've convinced you of that. Like this is one side, this is like one pyramid, and so I'm definitely, all of these are going to end up being J in fact, and then this is your other pyramid, so all of these are going to be K when we bring it together. They're all going to lie on in the same point as I've shown on the diagram. Okay, we're told that the side of each square in each triangle is 1 centimeter. So this here is going to be 1. What we're left to find is the height of a square-based pyramid. So draw this out. We want to go from the very middle of the square up. Now, one approach is to draw a line all the way to here and a line going up one of the equilateral triangles. So remember, the square has lengths of 1 and the triangles do. So all of these lengths are 1, which means this length here is going to be a half. I'm trying to find the height. Okay, I need to find this length. Well, for that, I can draw one of the triangles out and recognize that it's actually the height of a triangle by itself. So for this, I've got a half here again. Now this is 1. And I can use Pythagoras to get the height. I hope I've made that clear. I've got my red pyramid. I've drawn a green triangle with a right angle in. I want to find the height. I know that's a half, so I just need to find this slope up one of the equilateral triangles essentially. So I've drawn that out, and I've drawn this in. We know the length is 1. This is a half, so it's going to be 1 squared minus a half squared square rooted for this height, which is then this length here. 1 squared is 1, a half squared is a quarter, so it's going to be the square root of 3/4, which I could write as √3/2. So that becomes this length here, √3/2. And then I can do Pythagoras again. It's going to be √3/2 squared. That's the hypotenuse now of this triangle, whereas it was one of the shorter lengths for the triangle below, minus a half squared, square rooted, which is 3/4 minus 1/4 square rooted, which becomes the square root of a half, or 1/√2. And we found it. That is our answer here, 1/√2. And this is also 1/√2. So my overall length is 1/√2 plus 1/√2, which is 2/√2 plus 1 from before. Now, 2/√2 can also be written as √2. You can either, if you've covered this topic, think about rationalizing the denominator, times top and bottom by √2 to make it 2√2/2, and then these cancel. Or you can just understand that when you divide a number by its root, you get back to the square root. So the answer is going to be B. I just very quickly want to talk about an alternative method for finding the height. Actually, I don't know, this is how I did it when I originally did the question. So instead of drawing the right angled triangle as shown here, I could in fact draw one going from the center to a corner and then create this right angled triangle. I'm going to do that again. I think it makes sense to draw the height in first, and then it's going to be going this way. Maybe it's a little bit harder to see, but that's a bit better. If I draw it on its side, you can see it a little bit better. So now this length here is going to be 1 because it's actually the edge of one of the right angled triangles. And I just need to find this here. So for that, I can consider my square, draw another right angled triangle, but this is now a half and this is a half. So it's this diagonal length is going to be a half squared plus a half squared square rooted, which becomes a quarter plus a quarter, which is a half. Square rooted is again 1 over root 2. So that length is 1 over root 2. That length is 1. So for the height, it's going to be 1 squared minus 1 over root 2 squared, square rooted, which becomes 1 minus a half square rooted, which again becomes 1 over root 2. So just an alternative way to think about it if you want, but either way, that's how we can get our height and hence the distance between J and K.